Hello everyone. In this video, we are going to learn about two important functionalities of Pandas. Of course, we are going to be using the data set that we cleaned in the previous video, the air quality data set. First, we will look at how we can be using the specific way that Pandas have for us to do loop. It's a very specific way that you can actually have the index and each row in every iteration of your loop. And then we will look at how Pandas also have its own way of mapping a function to all of the elements of the data frame. Basically, it's called applying a function. So this video is going to focus on these two aspects of Pandas. So let's get to it and learn about it. Alright, so of course we are going to be working with the data set that we cleaned in the previous video. This is very usual steps. A lot of the data analytics, business analytic projects come first. What comes first for them is that cleaning the data. I will see more of that in this course. But before we can read that, we need to import our module. So we import our module Pandas, and then we read that data. So you have to make sure that once you finish what you did in the previous video, you have to make sure that the Jupyter Notebook file is where this new file that you have created, basically clean your data set, are on the same folder. So once if you have that, you'll be able to read the data. It's the data that we cleaned in the previous video. So let's just jump right ahead and look at how it would look like if you were to use the for loop that is specific for Pandas. What's different about the for loops that is specific in Pandas is that you could be saying I want to be iterating or looping through all of the rows. So you can say it says df.iter rows, and then you also can say I want to have access to the index and also the values of each rows. So if I were to run this, I would be getting all of the indexes of this data frame. So let me go ahead and change this from head to just normal, so I would be able to see the first 5 and the last 5. So if I run this, I would be getting the print from 0 to 43,799. And that's what's going to happen, because at each iteration, all I'm doing, I'm just printing the index. So once I run this, as I expected, that's what I get. The print of all of those possible values. But if I were to print each row, what I would be getting, I would be getting a series for each iteration that has the information about each row. So there is going to be 43,799 different rows or different series that's going to be printed. So let's go ahead and print it and see how it looks like. So once we run this, we can see that all of these values, all of these chunks that are separated by this divider are one series. So you have the species, unit, state, year, month, day, time, and value. And if you go back, this is the name of your columns. And now you have these values that are accessible to you on each iteration. So on and so forth, this part of the code will be running until all of your data is printed. Of course, most of the time we don't want to print it, but we did this sort of like to get a better understanding of how the for loop works in Pandas. And if we were to check what each row is series, as we suspected. So let's do an operation here using loop. So we want to multiply all of the measurement by 1.05 and assume that this is a multiplication that all of the measurements needs to have. So if we were to do this, one of the ways we could do this is using a for loop. So basically you create a for loop, and for each of the iteration, you change the value that in the main data frame at the specific index and for that value, for the column value. And whatever you have value, row.value, you multiply that by 1.05. And this is just going to work. But let's just go ahead and see the result of it. As you can see, it just took a couple of seconds for this to work, but it did work. We had, we have all of the values that are multiplied by 1.05. If we compare these values to these values, we can see that that effect has been shown there. So this is a way that actually would work, but this is not the most efficient way to do these types of calculations in Pandas. The way you could actually go about this is by mapping a function, a Lambda function or explicit function, to your data frame. So here I have, I'm reading the the original data. So because I want to sort of get rid of what I already did to the data frame, and then I say map a Lambda function that multiply all of the values by 1.05 to the series df.value. So once I run this, I can see that this was run much faster. You can see that it was just happened instantaneously, and that's really the difference between mapping a function and doing what we are used to in programming by doing things in a for loop. So this is not something new. We already knew how to do this, but also Pandas comes with its own way of mapping a function, and that's called apply. Basically, you apply a function either to one of the series or the whole data frame. You could apply a function to a whole data frame. So first, let's go ahead and see how you can apply a function to one of the columns or one of the Pandas series. So basically, you say apply, and since you know what series it is that you're applying, you just basically pass your Lambda function, your explicit function, and this is just going to result in the same values. So as we saw, mapping or applying a function was much faster than doing it in a for loop. But let's go ahead and experiment this. So we are going to be using the module time to actually calculate how much time it took for each of these ways of doing the same thing. So on all of these codes, I am rereading the data frame, and I'm not calculating the time of reading the data frame. I'm calculating the time from right before the operation starts, and right after the operation ends, I report how long it took. So basically, right before the for loop start, I say what is the time now, time, and then I subtract what is the time after that time minus that start time, and that tells us how long it took for that operation to happen. So let's go ahead and run this. We can see that as we expected, we saw above, it took a couple of seconds. So here we have 3 seconds that it took for this to run. How about if we did it with by just mapping the function to the Pandas series? Once we do this, it's 0.01, and you can see the significant difference between these numbers. How about if we did it with apply? Even with apply is much faster. So you can see mapping or applying a function is a much better way of going about doing these types of operations. Not only it is faster, but also it's cleaner, and it makes much more sense and makes your code actually also much more readable. So there are a lot of good things about applying a function if what you want to do is possible by applying or mapping a function to your data. Another thing that we are going to learn before we finish this video is going to be what about I want to apply a function that engages more than one column. So in this example, we saw all of the operation we needed to do was only one column. So basically, we mapped or applied that function to just one collection, which was the Pandas series. But what if we wanted to we wanted to apply a function to a whole data frame, to each and every row? So for that, you actually have to sort of like imagine you have a function that each time that function is run, the input of this function is a series that represent each of your rows. So here, let's assume I want to apply a function that multiply only the NO measurements, not the rest of the 4 measurements, only the NO measurements by 1.5. So this function needs to have the capability to check if this series or this row is NO or not. And then if it is NO, then do that multiplication. So that's why it's a multi-column function. So as I said, we assume, so let's go ahead and do this first by an explicit function. We assume that one row of the data frame we want to apply this function to comes into the function. And we check row species, is row species NO? If it is NO, we will return the multiplication of the value by 1.05. If it's not, we return the same value. We don't change anything about it. So once we run this, now we created that function. It is known to the Pandas compiler. So all we need to do now here is to apply that function. So pay attention here. Now applying the functions to the data frame. So this is something you want to pay attention here. So before I was applying to the series of value, or to the column value, but here I'm applying to the function. I'm saying I want this column to be applied, and when you apply a function to a data frame, you have to pay attention that data frame doesn't know if you want to apply it across each row or across each column. And you can specify that by saying the axis. So if you pass axis 0, it's going to apply that function for each column. But if you pass axis 1, which most of the time you will do 1, it's going to be applying it for each row. So once I run this, now I can see very fast I only get the multiplication for the NO measurements and not for other measurements. So for me to be able to actually see this, there is like one trick, a slicing trick. You could say df ilog and get, you know, all of the indices from 0 to all of them by every 30 jump. So I will be able to see more of, let's do more than 30, every 200 jumps, every 200 increment. So once I run this now, I see 0 and then 200, maybe 200 is not enough. Let's do every 1000. Let's see if this changes anything. So now I have NO, I have NOx, and I have NO2 and all of them. Now I can see that what we are seeing is that only the NO measurements are the one that the multiplication sort of like had an effect on. Okay, so for practice, let's do the same thing, but this time let's do it as a lambda function. So here before we did this as an explicit function, but now we want to do it as a lambda function. It's the same thing, but we sort of like practice writing a lambda function that has an if statement in it. So we say lambda and we say this is a row. We just like, make it R because there's just one line and we don't have enough space. So we just say R instead of row. R, I want R dot value multiplied by 1.5 to be returned if the R dot species is NO, else I just want R dot value. And then I'm passing it to all the rows. So once I run this, I get the same result as I did earlier. Let's practice one more time, another example. So we want to update the column value in such a way that the values after 8 p.m. are multiplied by 3 and before 8 p.m. is divided by 2. So stop this video and try to do this on your own before continuing to watch. Give this a try before you continue. So the way you go about this, you could be doing an explicit function or a lambda function. What I've done here is a lambda function. And it's very similar to what we had before. So I'm assuming that this lambda function will get a row or a series that represent each row of this data. And I know this row has a value, r.value. And I want multiply by 3 to be returned if the time is after 8 p.m., which is 20. Otherwise, which means it's not after 20, I want it to be divided by 2. So once I run this, now this has been applied to this data frame. So let's use the power of applying a function to take one more step in cleaning this data set. So when we look at this data set, we have everything possibly to understand what day of the week this data was collected. So we know what year, we know what month, what day, and what date was it that this data was collected. So why not we add a weekday? And by that I mean I want to know if it was Monday, Tuesday, Wednesday, Thursday that this data was collected. So to go about this, we could take advantage of a function that the module's datetime have. The module datetime, if you pass the year, month, and day of a valid date to it, it will tell you what weekday it was. So once you run this, for example, today is 2020 November 30th when I'm creating this video, and today is a Friday. So once I run this, it tells me 4, and 4 is a code for Friday in this module. So I want to add a new column in this data frame that tells me the weekday. And to do this, using the module datetime, I create an explicit function that get the year, month, and day as an integer, as a number, and then return the weekday using the import module. So once I create this explicit function, now I can apply this function to my data frame, and the result of it will be added as weekday. So once I run this, and after that I also sort my df by time and species. So once I run this, now I see weekday, different weekdays, and also different values here that are recorded. So now I was able to add a weekday to my data frame, and this is going to show us a lot of capabilities for analysis based on each weekday. We might be interested to know about the pollution of a city based on each weekday, because human activities are sort of like societally changes, because on the weekends we don't have as much activity as we do over the weekdays. So that's going to be very useful for analytic purposes. Let's take one more step. Instead of these numbers, let's change these into Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday with 3 letters. So I have all of the possible 3 letters, and I know this is at the location of 0, 1, 2, 3, 4, 5, 6. And I create a replace dictionary by list comprehension. And basically I say instead of instead of that number, which is from 0 to 6, I want one of these values. So this is where that comes from, and this is the loop. So once I run this, it basically tells me wherever you see 0, put Monday. Wherever you see 1, put Tuesday, and so on and so forth. So once I apply this replace into my data, now I have a weekday that shows Sunday, the rest of the day. So let me actually also apply this sorting here. So we could be sort of seeing every weekdays. So once we sort this, now we can see all of those days. So now that we have this data frame that also has a weekday, let's also save this using the function toCSV to help us, keep what we did, or sort of, the updated version of this cleaning data that we did.